Welcome to today's webinar on cognitive load in science learning. So in this webinar, we will be going through how this cognitive load will, hit the students in their learning process. I hope my screen is visible for you all. So cognitive load in science learning. So why this topic matters? First thing is why we have to discuss about cognitive load in science, right? And how much is important this topic is. We will be discussing through this webinar, and also we will find the ways how to overcome this cognitive load in students. Okay. So the first thing is why students forget what we teach and how to fix it, right? So we have some of the teachers will be thinking like, I have taught very well, but still the students are not able to remember the things. So here are the reasons why. Students forget concepts despite of teaching, and science lessons overload memory. Understanding cognition improves teaching. Okay. So what is cognitive load? Cognitive load is nothing but the mental effort used in working memory. And working memory has limited capacity. Overload blocks learning. In the next slide, we will be going through these mental effort, what exactly mean mental effort means what, and how does this memory, affect only to a limited capacity. All these things we will see. Uh, so these are the types of cognitive load is intrinsic, extraneous, and germane. So these are the types of cognitive load. Now, when we go in depth with intrinsic, that is nothing but concept complexity. I will give an example for you. Whenever you are teaching for grade like 4th, 5th, or 6th standard, so we have a chapter physical change and chemical change. So in this intrinsic, again, we have two types of intrinsic, that is low intrinsic as well as high intrinsic load. Now, load, that is low intrinsic load means, with an example I will be explaining you, that is physical change. So physical change, we will explain them that melting ice and tearing paper, these are the examples of the physical change. Okay. So, and apart from that, if you see, uh, there are many examples, and we are keeping it to a limited examples. We are not crossing, or we are not giving too much of examples for this type of explanation. So this is only one idea, no new substance formed. Our intention is to explain the physical changes, to explain it that no new substance is not formed. This is low intrinsic load. That is, there is no much explanation. What has to be explained, that is explained to the point, right? And now high intrinsic means where we will try to elaborate many topics in this, right? Where the students get confused. Example I will take, same, the chemical reaction. So in chemical reaction, we need to explain them reactants, products, energy change, conservation of mass, right? Conservation of mass, all these things we are supposed to explain to the student. This is high intrinsic load, where the child may have this complexity of understanding the concept, because it has multiple ideas working simultaneously. So when there is multiple ideas working simultaneously, the students feel like it's like a little bit difficult to understand the concept. Why? Because they have to go through 3 to 4 topics at a time. So this is intrinsic cognitive load. Now, when we are talking about the extraneous one, it's a poor instructional design. Poor instructional design means, first let me explain you what is extraneous cognitive load. See, mental effort wasted on how information is presented, not on what is being learned. So, rather than understanding the concept, so learning instead of concentrating on the learning process, they will just try to observe how the presentation has been done on the concept. So that we call it as extraneous cognitive load. Now, what causes this? This is example I would like to tell, like science diagrams. We have in science, we have diagrams, and they are not, presented properly in the textbook. Uh, Example like diagram is on one page, the labels are on the other page, and the explanation related to that is on the other page. So this makes the child, you know uh, they have to constantly shift their eyes. Once they're shifting their eyes, their memory is not stable. So even this type of explanation will lead to type of cognitive load only, right? uh, so better what we are supposed to do is try to keep the diagram and the labels with short explanation related to that labelings in one page, so that the students can easily understand what exactly is going on. Or else definitely the child will think that no, I'm seriously not getting, because the to see the diagram again, the child has to go to the previous page, and then to exactly know which part is labeled which number, they have to come to the next page, and to learn what exactly it is, to see the definition of that, it has to go to the another page. So this kind of disturbance, we call it as extraneous cognitive load. That is, in short, the instructions are not given properly in a set. That we call it as extraneous cognitive load. Now, how to improve this? It's one proper way to overcome this extraneous is, as I said, keep each and everything simple and in one side or one place. That would help the students to concentrate more and easy to understand the concept. Do not spread the things all over the book. As well as the next, germane. So now what is germane cognitive load? Germane cognitive load is nothing but the mental effort used for thinking, organizing, connecting, and making sense of learning. So this exactly what we have to look into. We being teachers, we are not supposed to get into intrinsic or extraneous. So our simple thing is we have to follow this germane effort of understanding. That is, we have to make the students to properly organize their thinking and connecting and making sense of learning, which means that whatever we explain, it has to be in a proper flow. That is what germane cognitive load is. And this is a very good one. It doesn't create any such overload to the children or the students. We are supposed to encourage, or we are supposed to use this sort of cognitive load. And look, this clear explanation and organized explanation will help the students to understand the concept in a proper way, and they will understand it deeply. So rather than going to intrinsic, extraneous cognitive load, we being teachers, we are supposed to look into germane cognitive load. In the next part of this session, I will be explaining you, or I will be giving you the examples how to overcome this one, or what type of activities will help to overcome intrinsic, extraneous, germane type of cognitive load. Okay. Some teachers may ask, sir, you said a germane effort. Now, how to create such, the explanation, keeping it, short and simple, and even using the diagrams also. Yes, we have that each and everything. In the next part of the session, definitely I will be showing you how to overcome these cognitive loads. So next, working memory limitations. In the first slide, we have seen that cognitive load creates or it restricts the student for only a very minimum limitation of memory. Now, what can cause or how it is related, like memory, shortening the memory? Because first, let me tell what memory limitations means. It means that the students are able to only process the limited information, and too much input causes confusion. And all these, that is, these both reasons lead them to rote learning. So where they will not understand the concept, they will memory limitations. So only limited information means, now suppose think that I am teaching evaporation, definition. I'm teaching that concept evaporation. So when I'm explaining about evaporation, I have to go through so many things. That is recall evaporation. I have to connect that wind with speed, right? And even I have to apply it for the real life. So when I'm trying to do all these three different things, the student might, they will not be able to grasp all these things at a time, which makes them like what? Only limited information they will store. Example, I will tell, if I'm recalling what is evaporation or I'm connecting it to wind speed, only till that the student or the child may understand. After that, we don't know. The next part, completely makes them to feel confused. Okay. So, and when they get confused, so they themselves will put themselves down saying that no, I'm not able to understand this concept. It's very difficult for me. And science is, it's a kind of a difficult subject. So just to pass on, what I'm supposed to do is I just buy had the things and keep it as simple as that. So that is what exactly it means. And now, mm, a few more examples if I would like to give on this is on the limited information. Capacity is very limited. Okay, and the information whatever they have received from the teacher, whatever the concept they have understood from us, it stays only for few minutes or few seconds. Suppose, and the very next day if you come and ask few questions related to that, you will be able to see only few of your students will be able to answer it. Remaining all, they are quite, they don't want to answer it. Why? Because that has erased from their mind. Okay, why? Because that has erased from their mind. Okay, why? Because of the confusion, right? So that is, in short, if you want to tell limited information means it stores only for few minutes or few seconds, right? Now what we are supposed to do, we'll see what we are supposed to do or what are the main reasons again for this one. These are the few more reasons. Cognitive overload in science, dense textbooks. First, only the student have been confused in all those limited access of the information and all. And apart from that, these are also the reasons for overload. Dense textbooks, okay, crowded diagrams, multiple formulas at once. Okay. Mm, example, we'll see in the next slide. So what we are supposed to do with diagrams, keep it as simple as possible. Do not, club multiple concept at once. Let me explain this multiple formulas at once with an example. In grade 7 and 8, we have a formula for density, right? Okay, density is equal to mass by volume. Um, if we just explain the students that, okay, children, density equals to, it is mass by volume, right? And in the problem, you will be finding what is mass, what is volume, and they will ask you density this way. You know, it is quite difficult, and we are supposed to explain, or if you just explain the formula, and you will get the reactions from the children in this way. The students definitely will ask this, sir, which value goes up, which gets down, which means that they are confused whether I have to write mass upside or down. Even though we have written the no formula on the board, and if you change from finding density to finding mass, it's gone. Teacher has written clearly density equals to mass by volume. And when they are solving the problem, the teacher is asking to find mass. Now, this is unclear, and students definitely get confused. And definitely the first question what they will ask is, sir, which value goes up, which value goes down? Because they are confused, right? And why the question arises? First thing, we have not explained it properly. The second reason is they might have mugged up the or by hearted the or memorized the formula. That's what. So what we are supposed to do is, first, we being teachers, we are supposed to explain density, exactly what it is, mass what it is, and volume what it is, the difference between them clearly. In short, we are supposed to explain them and give some real life applications, examples. Okay, you may give so many examples and connect it to the real life, so that the child, without any confusion, understand it easily, right? So example, I will give you that is real life application. A stone sinks, particles packed closely. Now when we say why the stone sinks, because the particles in the stone, they are packed closely. So this is, what do we call, this is mass, right? A thermocol piece floats. Why it floats? Because it is the particles loosely packed. Now when we compare this with density, mass by volume, if we explain in this way, definitely the children will understand how the concept worked and where we are supposed to apply the formula. Um, but many of the students get confused in applying the formula itself. Why? Because they have not understood the formula. Try to explain the concept of formulas clearly. The concept behind the formula should be explained clearly. Next, related to diagrams, what we are supposed to do with the diagrams. Diagrams, if you see, many of the diagrams are just, unnecessary labelings will be given, and the diagram may be smaller one or bigger one, and teacher all of a sudden, instead of having a proper flow of explanation about the labeling of the diagram, they will just randomly pick the labeling and they will start explaining. That has to be avoided. Okay, and then teacher has to explain each and everything step by step. So first one is this, second this, it goes. That gives the clear image explanation, and there will be no confusion among the students. Reducing the load in equations, uh, explain meaning before formula and use symbols consistently. Avoid formula overloaded. Now, with an example, if I want to explain this, is in grade 10, we have chemical reactions, chemical equations and reactions. This chapter is the first chapter, and many of the students are confused in balancing the product as well as the reactants, right? Even though we have explained them this in 9th standard, but still they are not able to do it in 10th standard. Why? Because the way of balancing, explaining that is not up to mark. Almost all the children face this problem, right? And the next one is use symbols consistently. Previously, I have taken an example of density equals to mass by volume. If we take it in speed, so that speed distance equals to speed by velocity. So there is a confusion in this, wherein speed and distance we represent it as s. I think many of the teachers you might have observed it has been mentioned as s. So instead of that, this creates the confusion. Sir, distance we have to take as, or speed we have to take as. Sometimes we all know that speed is also, symbolized as v, small v. So this clarifies the doubt of the student, and properly they will understand it, right? No, chunking content. This is the basic thing for all the teachers what they are supposed to do. But still, many of the teachers, they will leave a effort like, okay, I'll just go through the flow. I don't need all these things. What is there in the content, I'll just explain it and I'll finish it off. But kindly go through this. Break lessons into small units. When you break lessons into small units, the advantage is you can explain the particular concept very comfortably and very effectively. That is the one main advantage of breaking the lessons into small units. If you don't do that, sometimes even we being teachers, we will jump into the different concept, and we will end up clubbing all the concepts, and there is no proper explanation. So teachers, kindly break the lessons into small units and always teach one idea at a time. Right. One idea at a time. Right now, I gave you an example of speed, distance, and velocity. Okay. So one idea at a time means first teach them how to calculate speed when distance and velocity is given. Right. The next step, you can ask them, once this is completely done, once you are confident that yes, children has understood that, then you can go to the next step, that is calculating the distance using speed and velocity. Until unless you are not confirming with the speed, if you go to distance, the students will get confused. Again, in the next class, definitely they will arise the question, sir, for speed, which formula I'm supposed to use, even though you have explained in the previous class. So this type of load is generated just because of not properly explaining the concept. Okay. Now, frequent recaps. Recaps, this is necessary in some of the physics chapters, I guess. Even both like chemistry as biology also needed. But frequent recaps in numericals is very much, because many of the students say that numericals are very difficult. I'm not able to understand. I'm not able to do it. So as soon as you complete one numerical problem in physics or one concept, have a small recap, like 2 to 3 minutes recap, which will help the students to clear their any doubts if they are having. Okay. Example chunking, same thing like concept explanation, formula, then application. The next one is why students struggle in numericals. If you have anything to say, teachers, you can just drop your messages in the chat box so that I can see it and I will address it accordingly. Right? Thank you. So, why students struggle in numericals? Thank you. So, why students struggle in numericals? The first and foremost problem is like too many steps together. In the previous slide, I was explaining you go step by step, whatever you were supposed to explain, make it into small units and then explain it. So same way here, the students are confused because there are too many steps are there. And again, formula confusion. which formula I'm supposed to apply, which one we are supposed to, work on this. That's a big problem, right? All these causes again what? Cognitive overload. Teaching problem solving. So explicit step teaching. Now, what is this explicit step teaching? First, we'll understand exactly what is this explicit step teaching. Why cognitive overload causes? What are the reasons? Whether the teacher is not going to do it properly or the students is not going to intake it properly. If it is from teacher side, then how? So that is the first point we have here, explicit step teaching. This is nothing but what? Breaking problem solving into visible, repeatable steps and modeling each step clearly. This is what explicit teaching means. This is the step. I repeat once again what exactly it is. Here, we are breaking down the problem. It is not only the problem, it may be the concept also. Whatever you're supposed to teach, even it may be a diagram also, where they have to draw it, right? So this explicit step is applicable overall for all type of concepts. So breaking problems, solving into visible, repeatable steps and modeling each clearly. Okay. Now in this, students don't fail because this process, it's like a hidden type, because it's all done by the teacher in the background, and a proper process, a proper flow of teaching is presented in front of the teacher, in front of the students, which makes the students as if the science is easy for them to learn. But background, background teacher has to do so many works. Now implicit, okay, worked examples. uh, Worked examples, what we does is, we just solve the textbook numerical problems, and just the remaining part we will give it to the students, like, okay, student, I have solved two problems and I have explained how to do it, kindly do it. Now the problems what we have solved and the problems what we have given as a homework, there may be a lot of changes, may be change. So what we are supposed to do is, this is what we are supposed to do. Okay, the teacher explaining error very less in the students of time on the error. Okay, so we were on this page, we were discussing about the teacher solves first, student observes. So this reduces the confusion in the student. So they thoroughly follow the teacher step by step. Sorry, there was a little technical error. So I will share my window exactly. So we were talking about how exactly we will come to know that child is going through, cognitive overload. So it is like frequent small mistakes. Even though we give a very minimum small work, the child is, totally confused. Arey, what is this side of homework, what I'm supposed to do, how I'm supposed to finish it off. Yes. uh, the questions I will be taking in the end of the session. Is that okay? Maya Devi. So the frequent small mistakes, poor explanations, and surface learning. So these are the signs of cognitive overload, right? So kindly keep an eye on the students, like wherever we see, we being teacher, we feel like we have given our 100%. Whenever we are done with the class, we feel like, yes, I have explained everything properly and I have done my job 100%. But when we see it in the student's perspective, exactly we will come to know whether we have given 100% or no. Okay. The next, teacher design choices. Even these also matters a lot. Teachers should have this habit of clean board work. There should not be a hash posh on the board. If you are writing anything, if you're mentioning anything on the board work should be neat and clean. The students, if they want to see and learn from the board, it should be quite clear for them, understandable. It should not like what I don't know what the sir has written on the board. It's clearly ununderstandable. I cannot understand it. That should not be the scene, right? And use very simple language. You have supposed to use very simple language, since they are the kids, they are like grade below 10 grade students. We don't need to use a high language or the first sophisticated language. No need to use all those things. It's a simple language which the student feel. Why we are doing all these things, the clean board and simple language, it you know emotionally as well as mentally affects the children. I will tell you an example. If the teacher is not keeping the board clear, student may think that, oh, I don't know, maybe I have done mistake or I am not able to understand what sir is written. So mentally the student will put himself down. Simple language, if you're speaking the words, the vocabulary you are using, which are very on a high level, the student are not able to understand the word, what you have explained. Again, they put themselves down that I'm not that up to mark in English language. So please do take care of these 2 points. Logical sequencing. That's what. Explanation should be in a proper sequence. Cognitive load friendly teaching. Try to keep this depth over coverage. That is, uh, instead of explaining each and everything, try to minimize it where you can explain the difficult topic in a simple manner. Understanding before speed. We don't need to rush. I know many of the teachers, they will be rushing because we have to supposed to complete the syllabus. So they will just rush. So we don't want that. Let the student understand. Until the student understand, we don't have to move to the next part of the topic. Let them understand, then we'll move. So this is understanding before speed. Clarity over quantity. Uh, Example, like in chemistry or physics, we will be giving a lot of numericals. No, we don't want to do that. Why we will do it? Let the children, practice and be perfect. See, if we are giving n number of problems or 20, 30 problems to solve on same concept, do you think the children show interest? No, because they don't have the clarity on the concept, so they will not do all those things. Again, they will copy it from someone else and they'll submit it. What if there is a clarity, proper clarity of the formula, and you give 4 to 5 examples as a homework? Done. So clarity over quantity. Quick classroom tips, one diagram at a time, one formula per step, pause and recap. Do not use multiple diagrams to explain, right? Do not write multiple formulas until unless you explain one formula. Do not write the another formula. Always have a proper pause and have a recap. Ask the questions related to the concept. Key takeaways is overload causes forgetting. Teachers control cognitive load. Everything. This cognitive load is, it depends on teacher. No one can control this. So final thoughts, what we have is students forget due to overload. Better design leads to better learning. Now we have discussed about all these, the problems it may be or the queries it may be. Now, how to get, no, how to overcome all these things? You might have gone through our textbooks. Till now, we have discussed about the minimum explanation, point-to-point explanation, okay, and not mixing up the concept, right? And the explanation should be up to mark. Diagram should not be jumbled. Proper diagram should be there. So how do we do it? These all things we have done it in our next part book. I'll just show you the things. So this is the first one. Activities explained in simple way. Okay, this is sixth grade book we have done. So you can see that the activity, the question is explained in a simple language. We have not used any of the sophisticated words over there or high-end words over there. No, it is very common to the students and they will understand it easily. Below that, we have given steps in the scientific method. So instead of giving it in a complete paragraph, we have broken it or we have separated it into step by step. Questions are there, hypothesis is there, experimentation, conclusion. So when the child sees this, so he will exactly understand that, okay, activity means when we do some experiment, so this is what we are supposed to have. That is, in that questioning will be there, hypothesis will be there, experimentation, what we have done, and last conclusion we are supposed to write. So this way, we have explained the activities related to experiments very simple way. Okay. The next one, overthinking about a wrong concept. Now, when we have this overloading, cognitive overloading, in the beginning, I have explained you about intrinsic overload, that is low intrinsic and high intrinsic. It falls under that. So when we give them so many concepts, they will get confused and they will misunderstand the concept. So that type of any concepts are there. We have clearly explained in our books. Each and every chapter will have this misconception and fact. Okay, you can see that once a question is answered scientifically, it remains the same forever. That is the misconception. What is the fact? New experiments and discoveries can lead to revision or a completely new understanding of the existing theory. Right. So many of the students are thinking that once some experiment is done and some theory is given, that remains completely for lifetime. No, it has to be changed. So this type of misconceptions are removed using this misconception and fact column. And the diagrams and the mind map you can see there, right? The diagrams are very simple and the labeling is also done. Alignment of the labeling is also perfect that students can easily understand. There is no mess up in labeling and unnecessary labeling is not mentioned here. And above that, you can see how the concept is explained. With the explanation, the differentiation is also given. So there is no much difficulty in understanding. The child will go through the diagram and will go through the the explanation as well as the differentiation between these two concepts, right? Beside that, we have mind map. It's totally related to the chapter. It's a small glance of overall the chapter, which topic falls under same subtopics. Everything is given in the mind map. So these are the steps what we have used to overcome the cognitive overload. And this is explanation. Example I have just shown you, diversity in animals. Movement and locomotion is the explanation. And you can see we have kept the explanation very minimum. There is nothing such like, yeah, I have to elaborate it for a half a page or 1 page, then only the student will understand. No. What are the main point? What is required to understand? Only those things have to be explained perfectly. That is what we have done in this. We have not unnecessarily explained or unnecessarily added any content over there. Very precisely, what is necessary, only that much we are doing it. Even this activity also, right? These activities, even you can see the QR code over there. The child will watch the QR, use the QR code and then watch the AV module related to this activity. And then he will mention the outcome in the space given in the book. So there is no cognitive overload in the books what we have done. It's very simple to understand, right? Um, so that's all. If you have any questions related to this, you can ask. I can see that Maya Devi has raised your hand. So if you want to ask question, you can ask. Keshav. Yeah, sure, please. Definitely. Yeah, yeah. Okay. Any other things you're supposed to ask? We have another 5 to 10 minutes. You can go ahead and ask me the questions. So teachers, kindly keep your explanation point to point. Prepare well. Do not confuse the students. Okay. And you have seen these, the components, what we have used on the screen, they are very precise. I think if you're, going through our textbooks, you'll really understand this. Okay, the feedback form has been given. Kindly share the feedback. Yes. Anything else if you want, can ask. We are here. Yes, Keshav, it has been already shared to you. I hope there are no questions or doubts. Thank you very much. Thank you very much for the session. Have a nice day. Thank you. Uh, Sorry. Feedback form is there in the message. Kindly chat box. Kindly enter the feedback, fill it and submit it.